Okay, question 2. A and B are pretty much identical to question 1. Part C is a little bit more involved, and the giveaway there is you've got 6 marks for that. So, looking at part A, we want to know the acceleration of P in terms of I and J. Well, as before, we've got a velocity at time t equals 0 and a velocity at time t equals 4. So we're looking at a change in velocity divided by the time taken. So, acceleration, change in I is going to be minus 5 minus 3, and it's in 4 seconds. And it's going to be plus 11 minus 5 all over 4j. And that all simplifies down to minus 2i plus 4j. Part B, again, virtually the same as the first question. We're going to use F equals ma. This time, mass equals 3 kilograms, and acceleration, as we've just worked out, is minus 2i plus 4j. So, force equals 3 minus 2i plus 4j, which is minus 6i plus 12j. That, however, actually is a vector answer, and we're looking for a magnitude. So, in fact, the actual answer we're looking for, magnitude of f, we're going to be using Pythagoras. And as before, square root of 6 squared plus 12 squared, which is 6 root 5 newtons, which is approximately equal to 13.4 newtons 1 dp. Part C, as you said, a little more involved reading the question. At time t6, P is at a point with vector 6i minus 29j, and we're trying to find basically where it is 3 seconds after that. So the first thing we're going to have to do is find the velocity at 6 seconds. So velocity at 6 is going to be 3i minus 5j, which is its initial velocity, going back to v0. And then this time we're going to add 6 lots of acceleration, minus 2i plus 4j, which becomes 3i minus 5j minus 12i plus 24j, which is minus 9i plus 19j. So when it gets to point A, it's moving with that velocity. So its position at point B is going to be the position vector of A, 6i minus 29j, and again it's going to be with 3 seconds worth, so adding 3 seconds of this velocity, so plus 3 minus 9i plus 19j, which all drops out as minus 21i plus 28j. Now that's the position of B, but the question's asking us for the distance of B from O. That's a position vector, so distance OB is going to be, again back to Pythagoras, square root 21 squared plus 28 squared, and in fact that drops out 35 meters.